Okay, welcome back. In this lecture, it's going to be kind of a shorter one. I'm just going to talk about adaptations. So previously, let me go back a slide here, we learned about Charles Darwin and his theory of evolution. And the reason why he is credited for the theory of evolution is that he actually could explain how organisms do change over time through the process of natural selection. So the process that drives evolution is natural selection, and the outcome is that we do see changes in species over time. And so just to recap what natural selection was, it's a process by which populations of organisms with variations, and these variations help them survive in their environments. And if that variation can be passed on to the next generation, these individuals will live longer, they'll compete better, they will reproduce more, and in the next generation you will see more of that variation. So you kind of need to have 4 parts or 4 steps to it. First off, that variation. It has to be heritable, okay? It has to be genetics, right? It's got to be on a chromosome. It can be passed from one generation to the next. Reproduction, the ability to pass it on to the offspring. That variation has to allow individuals to survive, so it gives it an advantage or benefit of some sort, and then over time more individuals will have that variation. So adaptations is when that inherited trait increases the organism's chance of surviving. Okay, increases their chance of surviving and reproducing in their environments. And so there are 3 categories for adaptations. And so we're going to go through each one here. First one's called structural adaptations. So structural adaptations are basically physical features that you can see. You can see the color, the shape of it, the size. And so on the Galapagos Islands, we noticed that with different species of tortoise, they had different neck lengths. Some were long, some were short. Or with the finches, different beak sizes. Some were large, some were small. I talked about the peppered moths, the color, the dark melanic coloration versus the white, powdery gray coloration of these moths during the Industrial Revolution. So structural adaptations. That one's pretty easy to identify. Okay, so something about that physical feature gives it a slight advantage. The long neck, they can reach food up high. The short neck, they can reach the food down low a lot easier. The coloration of the moths, it has that camouflage purpose of it. The finches, the size of their beaks. The larger beaks could crush bigger seeds. Okay. Behavioral adaptations tie into how the organism acts. Okay, so if it's nocturnal, being maybe nocturnal in a very hot environment gives it an advantage. It doesn't, or it doesn't lose water much, or I don't know, but maybe it hunts at night because it's got really good eyesight, or that's the food source that it really prefers is at night. So behavior adaptations, how the organism acts, and does it give that organism a benefit. The third type of adaptation is called functional adaptations, and this one's harder to pick out. I feel like it's a change in internal body systems, so inside the organism and or its biochemistry. So your book talks about jackrabbits, okay, and how their large ears allow blood vessels, like the blood vessels in the ears, to help the jackrabbit cool off. So as the blood is traveling through the blood vessels in those ears, which is a very thin membrane, it helps the jackrabbit cool off faster in hot conditions. So we are going to do something called the Adaptation Project, where you're going to select an animal and identify a structural adaptation, a behavioral adaptation, and a functional adaptation, and then sketch it, and then point out where these adaptations are, and then explain those adaptations. So excuse me while I jump ahead. So in your notes, I sketched a wallaby. Now, obviously up here, this is not sketched. I took this picture from the web, but in the notes, I actually sketched it. Okay, so you will have to sketch your organism. And I know all of you are like, oh, Mrs. Erickson, that's way too hard. Well, you know what? Maybe we can find something else for you to do, but I really want you to sketch it, okay? So I chose the redneck wallaby for my example. And so let's just go through each of these adaptations and then see if we can identify it as either structural, right, behavioral, and functional. So red-necked wallabies keep cool by licking their paws and wrists. This uses much less water than sweating. So they're constantly licking their wrist. Is that structural, behavioral, or the internal chemistry one? Okay, hold up, timeout. Yep. Okay, I'm supposed to have these things that are supposed to appear, and I couldn't find where it was. Yes, so this is behavioral. So they're acting in a way that gives them an advantage. They're licking their wrist. Wallabies have the ability to store elastic potential energy in their tendons within their hind legs, allowing them to propel themselves with little effort. Structural, behavioral, or functional. This is structural. Okay, so they're talking about the physical characteristics, these hind legs that are super powerful and springy that allow the wallaby to move quickly in its environment. The red-necked wallaby has a natural-born instinct to flee at the first sign of danger. Is this structural, behavioral, or functional? This should be behavioral. Okay, they don't mess around with danger. They run away from it as fast as they can. Mother wallabies have the ability to temporarily freeze the development of an embryo during pregnancy. How cool is that? So this right here, this is happening within the organism. This is functional. So the mother, if she's developing a unborn wallaby inside of her and conditions are, let's just say the conditions are terrible, drought, low food, she can actually freeze the development of that embryo until conditions are good, until food is abundant again. The muscular tail of the wallaby serves as a steady and rudder when leaping and can function as a third leg when the wallaby is resting. Roll right away. After you read the muscular tail, boom, you should have been like structural. We are talking about a physical feature of this organism. So this is structural. So your project is you will need to choose a animal. I'm allowing you to choose your own animal, but the animal you choose, okay? Don't start sketching right away until you have found a behavioral adaptation, a functional adaptation, and a structural adaptation. You just need one of each. Okay, notice I have multiple here. You just need one of each. Really, you just need 3 total, but it has to be one of each. If you'd like to do more, you sure can. So there will be an assignment posted on Google Classroom, and that's where you will complete this assignment. All right, that does it for this lecture.